All right, I'm giving you guys 7 problems to do independently because I'm going to breeze right by them. Find the solution set by factoring and zero product principle. And then we're going to do the same problems, but with the quadratic formula. So these 7 problems, please do them independently because I'm going to breeze right by them. Okay? Okay, pause the video. All right, because now I'm going to start doing them. Okay, so if you did this correctly, what two numbers multiply to positive 16 and add to positive 10? That combination is going to be positive 2, positive 8. 2 times 8 is 16. 2 plus 8 is 10. So we use, since a is equal to 1, that's going to be x plus 2 times x plus 8 is equal to 0. And then we use the zero product principle to split this into two cases. Either x plus 2 is equal to 0 or x plus 8 is equal to 0. And then we subtract 8 from both sides. One of the solutions is x is equal to negative 8. The other solution is x equals negative 2 because we subtracted 2 from both sides. So either x is equal to negative 2 or x is equal to negative 8. All right, number 2. The two numbers that multiplied to positive 36 and add to negative 13, that has to be a negative-negative combination, in particular negative 4, negative 9. Negative 4 times negative 9 is positive 36. Negative 4 plus negative 9 is negative 13. We win. So what does that do? That factors our quadratic trinomial into x minus 4, x minus 9 is equal to 0. Zero product principle states that we can separate them, basically saying either x minus 4 is equal to 0 or x minus 9 is equal to 0. So on the left equation, we're going to add 4 on both sides. One of the solutions is x is equal to positive 4. The other solution is we have to add 9 on both sides, and x is equal to positive 9. Okay, so either x is equal to 4 or x is equal to 9. Okay, number 3. Two numbers that multiply to negative 63 and add to positive 2, that is a positive-negative combination with a stronger positive. In particular, that combination is negative 7, positive 9. Negative 7 plus 9 is positive 2. So then we break this down into x minus 7 times x plus 9 is equal to 0. We break this up into two equations. Either x minus 7 is equal to 0 or x plus 9 is equal to 0. Let me just write that down really quick. So then we're going to add 7 on both sides. So that means x is equal to 7. Subtract 9 from both sides, or x is equal to negative 9. Two solutions for this quadratic trinomial equal to 0. Okay, number 4. X squared minus 18x minus 40 is equal to 0. This one was a little bit tricky because what two numbers multiply to negative 40 and add to negative 18? That has to be a positive-negative combination with a stronger negative. In particular, that combination needed to be 2 times negative 20, because 2 times negative 20 is negative 40. 2 plus negative 20 is negative 18. So what this does is this factors into x plus 2 times x minus 20 is equal to 0. So then we split this into two cases. Either x plus 2 is equal to 0, or x minus 20 is equal to 0. Okay, so then we add 20 on both sides. And x is equal to 20 is one of the solutions. Subtract 2 from both sides on the other equation, and x is equal to negative 2. So either x is equal to negative 2 or x is equal to positive 20. All right, let's take a look over here, because now we're going to do what two numbers multiply to positive 9, add to negative 6. That has to be a negative-negative combination, in particular negative 3 times negative 3, because they multiply to 9 and add to negative 6. Okay, so then that becomes x minus 3 times x minus 3 is equal to 0. Hey, wait a minute, they're practically the same thing, so all I do is just count one of them. So specifically, just x minus 3 is equal to 0. I'm going to add 3 on both sides, and x is equal to positive 3. That's the only one that works. All right, number 6 and number 7. All right, let's take a look at number 6. What two numbers multiply to positive 15 and add to positive 7? Okay, it has to be a positive-positive combination. Okay. All right, let's try 1 times 15. 1 times 15. 1 plus 15 is 16. Okay, that fails. 3 and 5. 3 times 5 is 15. 3 plus 5 is, that's 8. Oh, man. Well, I'm out of ideas. Moving on. Let's try the other one. Let's try what multiplies to positive 24 and adds to negative 3. Okay, that has to be a negative-negative combination. Okay, negative 1, negative 24, negative 2, and negative 12, negative 3, and negative 8, and negative 4, and negative 6. Those are my only options. Those add to negative 25, those add to negative 14, those add to negative 11, those add to negative 10. I don't know about you guys, but I'm getting frustrated because I've tried to find a combination and it doesn't work. Luckily, I've got the quadratic formula, okay? So now, take a breather, because this might be a long video. Okay, if you need to divide this into several parts, be my guest. Okay, so now we're going to do all 7 problems using the quadratic formula. So if you have one of those sheets where, let me pull this out really quick. Remember, you had one of these fill in the blanks. Okay, write down the name of the problem and fill in the blanks so that you don't get, carpal tunnel syndrome. Okay, so without further ado, we know the answers ahead of time. Okay, we know that the answer to problem number 1 is going to be negative 2 and negative 8. So let's just get on with problem number 1. So now we're going to do this with the quadratic formula. Okay, problem number 1. Same problem, but now we're going to do quadratic formula. So if ax squared plus bx plus c is equal to 0, then we can use what's called the quadratic formula by plugging in negative b plus or minus the square root of b squared minus 4ac over 2a. So let's declare our a, b, and c. Our a is 1, just like all the other problems for today. The next video will have problems where a is not equal to 1. A is 1, b is 10, and c is 16. Okay, so without further ado, let's plug it in. I like putting in blanks because I don't like negatives confusing me. So negative b is 10, plus or minus the square root of b squared, 10 again, minus 4 times a times c, which is 16. All that over 2 times a, in this case, 1. Now, let's take a look over here. Negative 10, okay, well, there's no double negative, so that's just going to be negative 10, plus or minus the square root of 10 squared, which is 100, negative 4 times 1 times 16, that I believe is negative 64, because if you plug them into the calculator, right, get out of there, negative 4 times 1 times 16, that would be negative 64. So you would plug that in. So 100 minus 64, all that over 2 times 1, which is 2. Take a deep breath. I promise the more practice you get with the easy problems, the easier the harder problems will be. Okay, so now we've got negative 10 plus or minus the square root of 100 minus 64, that is 36, all that over 2 times 1, which is 2. And now, okay, I'm going to pay attention over here because now that the b squared minus 4ac has a value, in particular it's 36, it's a positive number. So because b squared minus 4ac is positive, that means that there are two real solutions. Okay, so b squared minus 4ac is positive. That means that there's two real solutions. So in particular, negative 10, all right, and 2 over here, the square root of 36 is 6. So now we split this into the two solutions. x1 is equal to negative 10 plus 6 over 2, or x2, which is negative 10 minus 6 over 2. So now let's solve for the left part first. Negative 10 plus 6 is negative 4 over 2. So then we get negative 4 divided by positive 2, which is negative 2. Okay, so one of the solutions, x1, is negative 2. Perfect. Okay, let's do the other one. Negative 10 minus 6 is negative 16 over 2. And that means that the other solution is negative 16 divided by 2, which is negative 8, which is exactly what we got when we factored it for problem number 1. Compare the quadratic formula work with problem number 1. So factoring is a little bit quicker in this problem, but I want you guys to get comfortable with the quadratic formula because you'll see when it's useful. Okay? All right, number 2, same thing as the problem number 2 that we factored. We know the answer ahead of time, x equals 4 or x equals 9. So let's keep that in mind when we do this work. Okay, so first things first, the quadratic formula is here. Let's label our a, our b, and our c. So our a is 1. Our b is negative 13 this time. And our c is positive 36. Okay, if we want to solve for x squared minus 13x plus 36 is equal to 0, we can use the quadratic formula as well as factoring. So let's use the quadratic formula here. Negative b, even though there's a negative out here, I'm literally going to plug in negative 13 in the blank. Okay, I love the blanks. All right. Plus or minus the square root of b squared, yet again, negative 13, quantity squared, minus 4 times a, 1, times c, which is 36. All that over 2 times a, which is 1. Okay, so now let's clean this up. Negative, negative 13. A double negative, that creates a positive 13. Okay. So now 13 plus or minus the square root of, well, first let's do negative 13 quantity squared. Negative 13 times negative 13, that'd be positive 169. And now let's check in the calculator, because even I don't know this result, of negative 4 times 1 times 36. So negative 4 times 1 times 36, even though I don't need the times 1, I'm doing it just because. Negative 4 times 1 times 36 is negative 144. So now, 169 minus 144 and the square root, all that over 2 times 1, which is 2. A is always going to be 1 for today's problems. So now we've got 13 plus or minus the square root of 169 minus 144. That's going to be positive 25 over 2. Now that I've got a value as the discriminant, is it positive, negative, or 0? B squared minus 4ac is positive. So what that tells me is that there are two real solutions. Okay, now I'm going to split this into two cases, specifically 13 plus or minus the square root of 25, which is 5 over 2. Now, here's the magic. x1 is equal to 13 plus 5 over 2, or x2, 13 minus 5 over 2. Let's do the left side first. x1 is 13 plus 5, which is 18 over 2. 18 over 2, that's 18 divided by 2, which is 9. Hey, didn't we know that already? One of the solutions is x equals 9. Let's figure out the other one. x2 is equal to 13 minus 5, which is 8 over 2. So x2 is 8 divided by 2, which is 4. Compare that with the work that we did when we did just factoring. Okay, problem number 2. X equals 4 or x equals 9. We did that by factoring, but by quadratic formula, we also got x equals 9 or x equals 4. Same thing, just with the quadratic formula. Okay, all right, throw that away. Here comes problem number 3. Same thing, we factored this. Now let's get some practice with the quadratic formula because it's going to be useful. All right, so same old, same old. To solve this, we could either factor or plug in negative b plus or minus the square root of b squared minus 4ac, all that over 2a. And yet again, if you want to get into algebra 2, you got to know how to do the quadratic formula. So now, a is equal to 1, b is equal to 2, and c is equal to negative 63. I want to say no pressure because they do go over the quadratic formula again in algebra 2. I'm just trying to get you pumped because even though it's algebra 1 curriculum, they do go over it again in algebra 2. All right, so now let's plug in all the values. Negative b, well, b is 2, so I'm going to put a negative 2, plus or minus the square root of 2 squared, minus 4 times a, which is 1, times c, which is negative 63. I'm definitely going to need a calculator for that. All that over 2 times 1. Again, all the problems today have a is equal to 1. Now, let's plug in negative 2 plus or minus the square root of 4, right? That's 2 squared. And then a negative 4 times a positive 1 times a negative 63. We've got 2 negatives, so I bet you it's going to be positive. Let's plug it in. Clear. Negative 4 times 1 times negative 63. We multiply these numbers and we get positive 252. So 4 plus 252, all that over 2 times 1, which is 2. Now, let's clean this up. Negative 2 plus or minus the square root of 4 plus 252, that is the square root of 256, all that over 2. Now, hey, same old. This b squared minus 4ac is called the discriminant, and the discriminant is positive. So if b squared minus 4ac is positive, that means that there are 2 real solutions. Okay, let me just put the focus on there really quick. Yeah. If b squared minus 4ac is positive, there's 2 real solutions. Well, I don't know the square root of 256 off the top of my head, so let me do square root of 256, and that is 16. Okay, so now we've got negative 2 plus or minus the square root of 256, which is 16, over 2. Now that the square root is, the discriminant is positive, we split it into an x1 and an x2. So now we've got x1 is equal to negative 2 plus 16 over 2, or x2, which is negative 2 minus 16 over 2. Let's do the left side first. So x1 is equal to negative 2 plus 16, which is 14 over 2. 14 over 2 is 7. That's one of the solutions. Let's take a look at the other one. x2 is negative 2 minus 16. That's negative 18 over 2. Negative 18 over 2 is negative 9. Hey, isn't that the same? Aren't those the same results that we got when we factored x equals 7 or x equals negative 9? Okay. All right. Number 4. What were the answers for number 4 last time? Just to give us a safety net. Well, remember, x squared minus 18x minus 40 is equal to 0. One of the solutions is x equals negative 2. The other one is x equals 20. We did this with factoring. Now that we know what the answer is, let's calm down and do this with the quadratic formula. So, without further ado, in order to solve x squared minus 18x minus 40 is equal to 0, we plug in the quadratic formula, negative b plus or minus the square root of b squared minus 4ac, all that over 2a. Memorize it. No, I'm just kidding. Have it available and know what to do. A is equal to 1. B is equal to negative 18. C is equal to negative 40. Plug in A, B, and C into the quadratic formula. So now that we know the quadratic formula, B is equal to negative 18, so I'm going to plug in negative 18 for that negative B part, plus or minus the square root of negative 18 quantity squared, minus 4 times A times C. All that over 2 times A. Let's clean this up now. Negative 18. Well, that's just positive 18. Plus or minus the square root of negative 18 quantity squared. I don't know that. So let me just plug that in. Negative 18 quantity squared. That's negative 18 times negative 18, which is positive 324. Then I'm going to do negative 4 times 1 times negative 40. So what's negative 4 times 1 times negative 40? That's going to be positive 160. Ooh, that's going to be huge. Positive 160, all that over 2 times 1, which is 2. So now I know that I've got 18 plus or minus, I don't know what 324 plus 160 is. 484. Once again, the discriminant, this b squared minus 4ac part, b squared minus 4ac is positive. So you'll see 2 real solutions. And these are a little footnote for myself. Okay, so this 484, right, is positive, so I'm going to find out what the square root of 484 is and bring it to justice. Square root of 484 is 22. So now I've got 18 plus or minus 22 over 2. Okay, so now I'm going to split this into 2 cases, x1 and x2. x1 is equal to 18 plus 22 over 2. x2 is equal to 18 minus 22 over 2. Let's solve for x1. Well, x1 is equal to 18 plus 22, which is 40 over 2. Therefore, x1 is equal to 20. Hey, that was one of the solutions when we did it with factoring. Let's do the other one. So now we've got x2, which is 18 minus 22, which is negative 4 over 2. And negative 4 over 2 is negative 2, which is exactly what we predicted when we did it with factoring. One of the solutions was positive 20. The other solution was negative 2. Okay. All right, put that away. All right. All right, number 5. Let's bring out the factored problem with this. So remember, we had x squared minus 6x plus 9 is equal to 0, and there was only one solution, x is equal to 3. Now that we know that the answer is 3, let's prove it with the quadratic formula. Okay, so first things first. X squared minus 6x plus 9 is equal to 0. Let's use the quadratic formula where a is equal to 1, b is equal to negative 6, and c is equal to positive 9. So specifically, negative b. Okay, well, b is negative 6, so I'm going to plug that in, plus or minus the square root of b squared, which is negative 6 quantity squared, minus 4 times a, which is 1, times c, which is 9. All that over 2 times a, which is 1. Okay, so now that we've got this out of the way, let's clean up. What's negative negative 6? Well, a double negative is a positive, so that'd be just regular 6. Plus or minus negative 6 times negative 6, that'd be positive 36. And then negative 4 times 1 times 9. Negative 4 times 1 times 9 would be negative 36. All that over 2 times 1, which is 2. Okay, so now I've got 6 plus or minus the square root of 36 minus 36, that's 0. All that over 2. Hey, wait a minute. Go back to your quadratic formula notes. B squared minus 4ac is equal to 0. So if the discriminant is equal to 0, that means that there's only one real solution. One real solution. So now I just drop it down. Sorry for the squiggle, for the cross out right there. I thought I was going to write more. But then, so this is literally going to be, who cares about this part? If I have 6 plus 0, that's just 6. 6 minus 0, that's still 6. So all I care about is 6 over 2, which is 3. So that means that the x-intercept, aka the only solution in this problem, is x is equal to 3. Quadratic formula, plug it in. Hey, wait a minute, the discriminant is 0, which means all I care about is this 6 over 2, which means that x is equal to 3 using the quadratic formula. Okay. Now, let's do number 6. X squared plus 7x plus 15 is equal to 0. Well, now let's go back to the factoring. I kind of just gave up on this one, didn't I? I mean, I couldn't really figure out what factors to do, because 1 times 15 is 1 plus 15 was 16. 3 plus 5 is 8. I couldn't really think of anything that multiplied to 7. So let's show this. Okay? So A equals 1, B equals 7, and C is equal to 15. I'm going to bring this problem to justice because it annoys me. That's exactly what happened. All right, now B is equal to 7, so negative B, which is 7, plus or minus the square root of B squared, which is 7, yet again, minus 4 times A times C, which is 15, all that over 2 times A, which is 1. Now, let's put all the pieces in there. Negative 7, so that's just negative 7. It's not a double negative. Plus or minus the square root of 7 squared, which is 49. Negative 4 times 1 times 15, so negative 4 times 15, that'd be negative 60. All that over 2 times 1, which is 2. Okay, now I've got negative 7 plus or minus the square root of 49 minus 60. That would be negative 11, all that over 2. Now I'm going to pay attention over here. What's the discriminant? Well, this finally puts some context as to why I couldn't factor. Because b squared minus 4ac is negative. So when b squared minus 4ac is negative, that's when there is no real solution. And that's the end of the problem. I can't factor because the discriminant is negative. It means that this problem is impossible to solve with reality. And I say that not as a joke, but in Algebra 2, you have to escape reality to solve this. And that's what's so appealing about Algebra 2. You go into a world called imaginary numbers. Say it with me now. Imaginary numbers. These problems only have a solution in your imagination, not in reality. So the answer literally is no real solution, because we're in Algebra 1. Okay, last problem. Remember, this one we couldn't factor either. I wonder why. All right, so x squared minus 3x plus 24 is equal to 0. So remember, a is equal to 1, b is equal to negative 3 this time, and c is equal to 24. Okay, so now we're going to plug in the pieces. Negative b, well, that b was negative 3, plus or minus the square root of negative 3 quantity squared, minus 4 times a times c, which is 24, all that over 2a, which is 1, 2 times 1. So now let's clean this up for the last time. Negative 3, that's positive 3, plus or minus the square root of negative 3 quantity squared, that's 9, and then negative 4 times 1 times 24. I'm pretty sure that's negative 96, but I'm just going to double check with the calculator. All right, clear. Negative 4 times 1 times 24. That'd be negative 96, just like I predicted. So 9 minus 96 over 2 times 1, which is 2. 3 plus or minus the square root of whatever that is over 2. 9 minus 96, just to get it right, 9 minus 96 is negative 87. Okay, so tell me about this discriminant one more time. Well, kind of like problem number 6, I had an issue factoring this. Specifically, the b squared minus 4ac is negative. So what does that mean? I can't take the square root of a negative number. It's impossible. That means that there is no real solution. And that's the answer. Let me just box this because it's hard for me to hold this. So then the answer is there is no real solution. You plug it in with the quadratic formula. All the pieces fit in, but when you do the b squared minus 4ac part, that's why I love the discriminant, because this problem says it's not even worth doing. It's impossible to do. No solution. No real solution. In the next video, we'll be doing problems where the leading coefficient for ax squared will not be equal to 1. Have a good day and stay safe. Happy Memorial Day.